So if I give you log base 2 of 2, what's the answer to that? 1. Because this is the same, if you're using an old calculator, you would know this. Log base 2 of 2 is actually the same as log base 2 divided by log base 2. Because that's how they're typing them into their calculators every single time. Old calculators get typed in like that. And anything divided by itself is the same number, correct? The other way I told you is you could say 2 to what power is 2? 2 to what exponent is 2? 1. 2 to what exponent is 4? 2. 2 to what exponent is 8? 3. 2 to what exponent is 16? 4. 2 to what exponent is 32? 5. 2 to what exponent is 64? 6. You're seeing a pattern. 7. 8. You do have these notes. They're at the front of one of your notes packages that I've handed out to you. I think they're at the front. Are they in the middle? They're at the very front. Okay, that's what I thought. Okay? So we're going through the multiplication product or product law for logarithms, which we've talked about this already. So if we have log 2 of 4 plus log 2 of 8, that's 2 plus 3, because log base 2 of 4 is 2, log base 2 of 8 is 3, so 2 plus 3 is 5, right? If we write it as a single logarithm, I told you that when we have additions, the key thing here, though, is that they have to have 1s in front. So this has to be a plus 1, and this has to be a plus 1. If they're not 1s, we have to do something with them before we can put them together. Okay? No, we'll have to do a power rule. So if they have plus 1s in front, we can put them together by multiplication. And let's prove that. So I can go log base 2, and then I can go 4 times 8, which is log base 2 of 32, which is what? 5. Same answer, isn't it? If I do them singly, or I put them together by multiplication, I get 5, either way. Correct? So this one, we'll do this one here, number 3. 2 to the what power is 8? 3. Plus 2 to what power is 16? 4. Which gets us 7. Now we can only put these together if they have the same base and they have plus or minus 1s in front. These ones have plus 1s in front. We agree? Same base, base 2. If one was a base 2 and one was a base 3, could do nothing. I couldn't put them together at all. Okay? So they're going to be log base 2 of 8 times 16, which is log base 2 of, sorry? 128. And the answer to that is 7. We have it above. So same with multiplication. We can only do it if there's plus or minus 1s in front. For multiplication, I have to be plus 1s in front. And same base, or we can't do it. Okay? So what's the connection between the first and last columns? How can we skip the 2 steps in between? Well, they say if you have log base A of B times C, let's say. So if I multiply it out. Most people are really good at this way. I'll show you. This way most people are really good. Log base A of B plus log base A of C. Most of you will say, hey, they're both base A, they have plus 1s in front. I can go log base A of B times C. Most of you can do that way. The way you guys are not so great is actually expanding it out as an addition. You're really good at seeing 2 additions go together as multiplication. That way, good. This way, not so good. So when I have 2 things multiplied, I can actually separate them by writing them as separate logs with plus 1s in front. So I could go plus 1 log base A of B plus 1 log A of C. Do I need to put the plus 1s in the front? No. I'm doing that to prove a point. So most people are really good at the second rule. Additions go together as multiplication. Most of you forget you can make multiplications out as additions. which is what we used for that other solving one we did. Remember that solving one we did on Friday and the one we did today on this board? We had two things that were multiplied, and I told you could separate them by 2 logs by addition. You just have to trust me till Monday. Here's the day. Here's the time. Okay. It's called the multiplication law of logarithms in the general case we given. So this is what's on your formula sheet. Log AM plus log AN equals log AM times N. And it works in both directions. No joke, it does. You guys just forget it works this way as well. Often separating them out is where people will sit for days and not know what to do next. So let's look at this one. Log base 2 of 15. Log base 2 of y. That should scream, put me together. Whenever you see the bases are the same, it screams, put me together. And you need to have ones in front. If you don't have ones in front, we're going to use power rule in a few seconds after division to get rid of those numbers in front. So this is a plus 1. This is a plus 1. So I can get log base 2 of 5y. Or 5 times y. You can put the dot in between. It doesn't really matter. It's still multiplication. I don't know why. I had a 15 on last class, and I changed it to a 5 too. I must be against 15s today. I'm not quite sure why. I'm like blocking out the 1. You all don't like make any expressions so I make a mistake wrong, and then it's just like if your eyes start twitching. Like I think she's wrong, but I don't want to say anything. Okay. Log base 3 of 9xy. I am not joking. This is the one you have to spot to separate. Okay? So you think there's not much you can do? You actually can. So this is what I do. If I see this, I immediately go log base 3 of 9 times x times y. Like I send it home to my brain to be like, I can separate those, right? So I put big multiplication dots in between them to remind myself maybe that I can do something, which I can. I can separate them by plus 1 logs. So I can rewrite this as log base 3 of 9, anything beside a log I put in brackets, plus log base 3 of x plus log base 3 of y. Can I do anything else? Yeah.
Are you combining log base 3 of 9?
Yes, which is? 2. So log base 3 of 9, if you don't separate these, you won't know that that could be a 2. So when you get a multiple choice answer and it's like something plus 6 or something like that, let's pretend. Okay? What's happened is these ones will have like x's and y's, so you can't do anything to them, like log 3x plus log 3y. Nothing you can do to them. But this one, let's say log 3 9 can turn to just a number because it's just numbers. The whole thing is just numbers. There's no variables. So if you see just a number sitting there, figure out how can I separate it so that this can happen. So 3 to the 9 is 2, or 3 squared, sorry, is 9. And so I get 2 log 3x. And sometimes they'll actually put them back together. This is the correct answer, and I would stop here. But sometimes they'll actually give the multiple choice like this. This is the problem with logs. Problem with logs is your answer's lovely and beautiful, it's just not on the multiple choice sheet. Because their answer that's there is actually this. 2 plus log base 3 of xy. They put them back together. Do you see how they can change the look? But it's the same thing. So sometimes they'll expand them out to reduce them, and then they'll put the ones back together that still have logs. Do you see that? Okay, I'm going to flip over.
Will you do that?
Yep. I just told you about it. It's not like it's going to be like brand new to you. You see how I did that there? Okay. Let's try it with subtraction. You can probably guess what's going to happen, but we're going to do it anyways. So log base 2 of 8 is 3. Log base 2 of 4 is 2. 3 minus 2 is 1. What do you guess we might do? Yeah. Now what I do, because sometimes you have more than one log together, this is what I note. And I want you to note this as well. If it has a plus 1 in front, like this one does, the 8 is going to go in the numerator. If it has a minus 1 in front, like this one does, the 4 is going to go in the denominator. Now, why do I state that? Because sometimes they have more than 2. So sometimes they have like log base 2 of 8 plus log base 2 of 3 minus log base 2 of 4 minus log base 2 of 1, let's say. Let's say not 1. Let's say 7. So now if I wanted to put these together, I'd go log base 2, and anything with a plus 1 in front would go to the top, anything with a minus 1 in front would go to the bottom, correct? So this 8 would go to the top, the numerator, yep. The 3 would go to the top, the numerator, and then I would multiply. Anytime there's more than 1, you multiply. The 4 would go to the bottom, the denominator, because there's a minus 1. And the 7 would go to the denominator because there's a minus 1. Do you see how, oops, do you see how you put them together? So it would be log 2 24 over 28, which would reduce to log 2 12 over 14. So anything with a plus 1 in front goes to the top. Anything with a minus 1 in front goes to the bottom.
6 over 7.
Yeah, I can keep going, but I've run out of room. I'm going to just erase that. Does that make sense? So the division rule that happens here is if you have log 2a minus log 2b, what's going to happen? If you have log 2a minus log 2b, what's going to happen?
Equals log 2 and
a over b. So remember, most people are pretty good because they're all the same base. So it'll be like 2, 2, 2, 2, 2. Most people are pretty good with putting these together. They're really bad with remembering that they can separate. So if I have like log base 2 of AB, and let's say I add a c to the bottom, remember I can separate that by going log base 2a minus log base 2b minus log base 2c. I should have that. And then it goes with the division rule that's on your formula sheet. Yeah.
I was just taking a look at the first question on this edit, giving an example of like the numerator number 3. It's 8 minus 16 equals 8.
Mm-hmm.
How would you do a question like that?
So this one here would end up getting you log base 2 of 8 over 16, which is actually a half.
Yeah.
So we would get log base 2 of a half. Now remember, a half can be written as what? Nope. 2 to the negative 1, right? Any fraction can be written as that number brought up to a negative 1. And then what happens when we have two bases that are the same? When we have this and this the same? The answer is exponent. Does that make sense, Jason?
Yeah, because then it doesn't match. It's equal.
Oh, it does. 2 to the 8 is 3. 2 to the what is 16?
And then
4.
going down and subtracting 8 minus 16 will not be.
Oh, you did the silly, silly part. Yeah, that rule's not real. Yeah. Yeah. Glad you're so happy. Okay. What about this one? Log 2, 15 minus log 2y. When you go log base 2, blah, 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 log base 2, blah, blah, blah. When you say base 2s in a row, they're screaming for you to put them together. I'm just telling you. Like, you don't even realize it, but in the back of your head, they're going, put me together. So, there's a base 2 and a base 2. What needs to be in front in order to put them together? Plus 1s or minus 1s. So I'm going to get log base 2 of what? 15 over y. And then this one, log base 3 of 9 over x. I'm going to get log base 3 of 9 minus log base 3 of x. And then log base 3 of 9 is 2 minus log base 3 of x. The purpose of knowing these laws is that we can simplify, solve equations of logarithms and exponentials. So we needed that one rule, the multiplication rule, to separate them by addition of logs to solve that exponential one we did on Friday, right? We're also going to need these log laws in order to solve when there's more than one log. So yes, it's lovely with number 3 here, I had one log, so I could convert to exponential. But if I have more than one log, I won't be able to do that. I'm going to have to do something first to get one log, which is using these rules. Okay. Now this is going to show you why the power law works. So we're going to consider 3 times 2 to the 5. Now I told you the power law on Friday, right? I told you the power rule. I told you that you could take that exponent, you could drop it in front if there's a log, or you could take it from in front and drop it up as the exponent if there's a log. I told you that. Well, this is why. So if you have log base 3 of 2 times 2 to the 5, that's the same as writing log base 3 of 2 times 2 times 2 times 2 times 2 times 2, correct? I literally could just write them out 5 times. Then using multiplication law, I could actually separate these all out by single logs, couldn't I? I could go log base 3 of 2 plus 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 log base 3 of 2s. How many log base 3 of 2s do I have? 5. So that's actually the same as saying 5 log base 3 of 2s. Isn't it? So that's why log base 3 of 2 to the 5 is equivalent to 5. You can take that 5 and drop it in front. Log base 3 of 2s. Because you just have 5 of them. So the power rule states that you can take that number only if there's the word log. Some people try and do it when it's an exponential and there's no log in sight. They try and drop it in front. But it only works if you have the word log in the middle of it. It's called the power law. It's on your formula sheet. It shows you log a base a of mn equals n log base a of m. And once again, it works both directions. You can take it from the front, bring it up, or take it up and bring it in front. Now what we did was we actually, when we were solving that exponential, we took the exponent, dropped it in front, and then distributed it. Correct? But what we're going to do today is we're going to figure out what times do we have to maybe move it up. So let's look at this one. We're going to simplify it. Log base 3 of 27. Or root 27. I don't want you to do this in your calculator. We're going to do it in our heads. Root 27 is the same as writing log base 3 of 27 to the what? Do you remember? Do you remember what the exponent is when it's a root? A half. Because remember, this is to the 1 and this is to the 2 index, and it drops underneath. Remember the 2 drops underneath? So you get 27 to the half. Now the easiest way to do any of this math in your head, and we're doing this actually without our calculators because they'll often give variables, and if you can't do them without your calculators, then you're in trouble, right? So how can I solve this without doing this without a calculator? Is if I can make 27 be base 3, life will be easier. What's 27 the same as? 3 to the 3, yeah. And then that has a half out. What do I do when I have an exponent and another exponent and they're like separated by a little bracket? Multiplication. So I get log base 3 of 3 to the 3 halves. What's my answer? Yeah, 1.5 or 3 halves. Because remember, when this and this are the same, my answer is the exponent. Because you just say 3 to what power gets me 3 to the 3 halves, so it'll be 3 halves. So if you can make these numbers be the same, your answer is just the exponent. Number 2, it's a little bit different. So I'm going to go start reading this and hope to see if something screams in your head. So I have a half log base 2 of 16 minus a third log base 2 of 8. What's happening here? Yeah.
stuff becomes a lot, so we can't like simplify.
Right. So you notice that they're both base 2 and we want to put them together, right? When they're both base 2, I'm not joking. It should. I wish it would scream off the page, put me together. Like I wish it would scream at you. But currently it can't be put together right now. Grayson is correct. Because I told you the only way they can be put together is if they have plus or minus 1s in front. We agree? So we have to use the power rule and bring these bad boys up so that I can actually solve it. So I'm going to get log base 2 of 16 to the half minus log base 2 of 8 to the third. And sometimes it's helpful to put the exponent in and sometimes it's not. These times the exponent going in is actually helpful. Because what's an exponent of a half? Just means the square root of, doesn't it?
Mm-hmm.
So this is actually the same as saying log base 2 of what? Nope, you were right with the 4. Because the square root of 16 is 4, right? And then we have minus log base 2. What's the cube root of 8?
2.
Now can I put them together? Plus 1 in front of this one, minus 1 in front of this one, base 2, base 2. Can I put them together? Yep. So I can go log base 2 of 4 divided by 2. It's division because there's a minus sign. So it's the same as log base 2 of 2. What's the answer to that? 1. You try 3 and 4. 4 is nicer than 3 if you want us to try 4 first. So what's the catch with 3? Now this 2 in front, this is a base 2, base 2, base 2, base 2, good. This 2 needs to come up as an exponent. So we're going to get log base 2. And then the x in the numerator. The 2x goes in the numerator multiplied. Why? Because a plus 1 and a plus 1. The x squared goes in the denominator because it has a minus 1 in front. And the y goes in the denominator because it has a minus 1 in front. So I'm going to get log base 2. Now this is 2x squared over x squared y. What cancels?
X squared and
The x squared, yeah. Now this is the catch. You have to watch yourself when you're doing logs on the diploma, on any unit test, on anything, because you'll stop here and they may not stop here. So what might happen is you might have put togethers and take aparts. You might have put togethers and take aparts all the time, or take aparts, put together, take aparts. Why would I do that for this one? It still has a single digit here, doesn't it? If I separate these, I can actually make it more simplified or into a different version. So I can go log base 2 of 2 minus log base 2 of y. And then I get 1 minus log base 2 of y. Now which one's more accurate? The one that matches the multiple choice or the numeric response. That's more accurate. Honestly, that's going to be your problem. You're going to have to try and match their answers. Correct? Number 4, log base 2 of 2. You could just say 1, but I'm going to try and put them all together first because they all are base 2. So I'm going to go log base 2 of 2, and then 3, and then 6, and then 8 go on the bottom. So I get log base 2 of 6 over 48, which is actually 1/8. Now what do I do here? Like I said, we're trying to do these without calculators, because what if they have this as log base a of 1 over a? As long as you can make the base be the same as the other one, your answer is the exponent, correct? That's what we said? So how can I make 8 be base 2? 8 is 2 to the what? 2 to the 3. Problem is, this isn't 8, this is 1/8. So it's 2 to the negative. And what's my answer then? Just negative 3. If you can make these be the same, your answer is the exponent. We're going to go down here. You guys can do that. Let's flip over. There's diploma style ones back here. So this is one I really like, because I don't really like it. I like showing you it because people get it wrong. Yeah. And if you get it wrong here and learn from it, you won't get it wrong on a test. Okay? This, if I can sell you one thing, this is the one thing I'm going to sell you. If the log does not have a base, if you put a base 10, your life will be much better in a lot of instances. Okay? For example, if it's a solving log and it doesn't have a base 10, it's sometimes hard to convert to exponential because you don't have the base, right? In this instance, I don't have a base, but I'm going to put a base 10 because it will help me. And 99.9% of the time it helps you. If not, it might just sit there and you wrote a little extra pencil and it didn't help you. Who really cares? Now, this is also what I told you. When I see things multiplied together or divided, I like sell it. I'm like, okay, that's 100 times a times b squared. What can I do with those? Yeah, set them into different laws and add them. So I can go log base 10 of 100 plus log base 10 of a plus log base 10 of b squared. Now I want to add a little more info to this question. So this is a good question, but they'll say this. They'll say, expand this, or they'll say, given log base, or log a equals 6, log b equals 2. You see how I didn't put the base and I want to write it as the base? This is my problem. Oops. You see that? So this is where the error will happen. Everyone watching? I can only replace log b with 2. We agree? Right now it is log b squared. So what people will do is they will go 2 squared, which is completely incorrect. I need log b. How do I get this to be log b? Yeah. Just move the 2 in front. If you remember to move the 2 in front, you will never get this wrong. You cannot square. This is log b squared. I can't replace log b squared. I can replace log b. This 2 needs to drop in front. Now, log base 10 of 100, 2. Plus log base 10 of a, or log a, 6. Plus 2 times log b. I now have log b, which is 2. You would have lucked out in this instance because 2 squared is 4 and 2 times 2 is 4, but normally that would not work. Like if it was cubed, it's not going to work. 2 cubed is 8, 2 times 3 is 6, right? Like it doesn't work. So you have to remember to drop it in front. So we get 8 plus 4, which is 12. So here's 1, 2, 3, 4, 5. There's so many. 6. Try them out. This one here, we would have log base 5 of 25 plus log base 5 of m cubed minus log base 5 of n. Log base 5 of 25 is 5 to the, what is 25? So that's 2. And then they'll drop the 3 in front. 3 log 5m minus log 5n, which is C. This one, if the square root is to a half, what's the b root? If the square root is to a half and the cube root is to a third, what's the b root? 1 over b. From grade 10, you learned this. You take this, write the exponent of 1, drop the b underneath, right? So it's log a to the 1 over b. What's your answer then? What happens when these two are the same? Your answer is the exponent. So it's 1 over b. If you make these be the same, your answer is the exponent, because a to the what power is a to the 1 over b? 1 over b, right? This one, we'd have to bring our 3 up first and our quarter up. So we would get log x 64 plus log x 8 minus log x 2, because this 16 to the quarter is 2. And so you'd get log base x of 64 times 8 divided by 2, which is some number. That is not 64 times 4. 256. This one's one of those that's split up. This one, I would start, bullet, start, bullet, bullet, start, bullet, start, bullet, bullet, start. I'm going to use Elsa. Yeah, exactly. Good singing. Glad it wasn't me. Now, I'm bringing Elsa in because this is one that is done just equally as poorly as the other one because it's not obvious. Okay? Let's look at this. We have log base A of 75 times A squared. Now that's fine. I can roll with the A and the A squared. It's what I can't roll with is this crap at the end here. Log base A of 5, log base A of 3. You gave me log base A of 75, Lepp. You suck. That's what I'm thinking when I first saw these. And then before, way back in the day. Yes. So what you need to do is make 75 broken up into these two numbers. How can I break 75 up into 5s and 3s? 5 times 5 times 3 is actually 75. 5 times 5 is 25, times 3 is 75, right? So you just have to break it up into these logs. So you're going to get log base A of 5 times 5 times 3 times, it's a little bit aggressive, A squared. And then I can separate them. So I'll get log base A of 5 plus log base A of 5 plus log base A of 3 plus log base A of A squared. Now I have log base A of 5s and I have log base A of 3s. I just didn't have 75, right? So log base A of 5 is the same as 7 plus log base A of 5 is the same as 7 plus log base A of 3 is 8. And then what's log base A of A to the 2? 2. When these match, the answer is the exponent. And it actually works out to be just one number. 15, 16, 17, 24. Who thought it was going to end up that way? Elsa killed the other two questions. 5 and 6 we're going to deal with tomorrow because we're going into solving logs, which needs this. So we're not dealing with, I'm not overwhelming your brains tonight. But I do have the review sheet that I want to hand out to you, or that cumulative hand in. So your homework. Yes. Oh.
Is our review still due tomorrow, or is it changed because?
I want your review due tomorrow. I want people to, not tomorrow, sorry. I want your review due by Friday.
What's the